Hello, it's Nivedita Kasturi, Department of CSE, Kerala Engineering College, Belgaum. Today we will be learning a topic called boundary value analysis or boundary value testing, which is the main functional testing method. Before I go to the main topic, I'll be dealing with what is testing, what is black box testing, and then we will understand what is boundary value analysis or boundary value testing and how to do the boundary value testing and with the different examples. Okay, as we know that in SDLC lifecycle, testing is the main phase, and the main intention of testing is to maintain the quality of the product. And here the test engineer doesn't do the testing with the intention of saying a developer has developed the buggy code, but the intention is to discover the error before our customer discovers it. Here I have listed some of the definitions for testing. There are many definitions, but here I have considered only two. First one is, testing is a process of validating and verifying that a software program or application or a product meets the business and technical requirement that guided its design and development. Okay, here whatever specifications or whatever behavior that is asked by customer, whether they have implemented as intentionally or not, we have to verify the different set of functionalities. One more definition is, testing can show the presence of bugs but never their absence. If I am testing a 10,000 lines of code, then it is for sure that there will be a single line of a code with a bug. I can identify a single bug. Now let us consider the black box testing, that is also called as a functional testing. During testing, we mainly test the behavior or functionality of the code or a program. Such kind of testing is called as a black box testing. The main reason why it is called as a black box testing is that here the test engineer who is doing the testing need not know the internal program or implementation details. He has to just know what is the set of inputs for this particular functionality he has to provide and what is the expected output, so that he can compare with the actual output. Under the black box testing, the boundary value analysis is considered. This is the most widely used functional testing, which mainly considers the input domain of the program or a module. To understand it better, let us consider a general example. P is a program, and then with the input y1 and y2, the range of these two inputs are A to B. For y1 it is A to B, and then C to D. For y2 it is C to D. If I want to represent this particular program in two-dimensional to specify its input space, it would be represented as shown in the slide. The basic idea of boundary values is, for a particular variable y, I have to consider 5 sets of input values. That is, if a value ranges from 0 to 10, then I have to consider the minimum would be 0 and then maximum would be 10, and then nominal value means I have to consider one in between value. It can be a 5, 6 or anything, and I have to one more value is just above the minimum, that is 1. Just below the maximum is 9. So these are the for particular input. I have to consider these 5 set of values for designing my test case. Before I proceed further, let us consider some examples to have better understanding. If if I have a large code in that one part is taking x value as greater than 10, then I would take its range from 0 to 9 for execution, for designing the test cases. If value given to the x is greater than 10, then some part of the code will be executed. If value given to the x is lesser than 10, then some part of the code will be executed. Here I'll be considering range as 0 to 9. I'll be doing the testing for 0 and 9. Instead of greater than, let me take less than. It would be better. Okay, the minimum value I will consider here is 0, not other than that, and then maximum value I'll consider here is 9. So if this is true, then this part of the code will be executed, otherwise the else part will be executed. Instead of using greater than, if programmer uses lesser than or equal to, then the range would be 0 to 10. Even if the value, the input value 10 is wrong, it will be considered for the valid input, because syntactically there is no error in if statements. They are correct. There will not be any compilation error for such kind of errors, for such kind of bugs. So it is better to do the boundary value analysis for all the input variables that I am considering for my particular program. I'll take one more example, that is password length. Most of the login pages has the username and password. While creating my code for that, if I take my password length as exactly equal to 6, instead of using that, if I take instead of equal to, if I develop the code with greater than or equal to, then the whole functionality of password will be changed. As there is no syntax error, this cannot be identified during the compilation. I have to consider this boundary value analysis or designing a boundary value test cases for such kind of inputs and then detecting the bugs. Most of the time, the developer will not do such errors intentionally. It happens by mistake or some typing errors. So most of the time, the logical operators like greater than equal to, less than equal to not equal to, and greater than and less than, these operators need to be verified carefully for the inputs. If these are used in some of the conditional statements or in the different kind of coding methods. Okay, that is boundary value analysis considers the single fault assumption. That is, it considers it as, means like there will not be any failure that are occurring with two or more faults. Means failure occurs rarely as a result of simultaneous occurrences of two or more faults. This is single fault assumption mainly considers if I have two inputs, that is y1 and y2. I'll be holding the one variable's value at its nominal and then varying the other variable's value. Here you can understand it better. See here, consider the y1 is, these are the different set of test cases that I have to consider if I am executing the test cases for my program P with a y1 and y2 as the inputs with a range a to b, c to d. I'll be keeping my y1 at the nominal value and then varying the y2 with all the 5 sets of input values, that is maximum, max minus, and then nominal, min plus, and then min. Similarly, I'll be keeping my y2 at the nominal and then varying the y1. This means the single fault assumption. Okay, you can consider some more examples here. That is, if the area code for a particular area is 200 to 99, it should be greater than 200 and less than 999. Then instead of using that less than, if a programmer uses less than or equal to, even though 299 are not the valid inputs, these are considered as a valid input for this functionality. To detect such errors, I have to go for testing at boundaries, that is at 200 and 999. Instead of testing the area code at its center like 700 or 600, I have to test it for 200 and 999. By this we understood that most of the time for any input the errors tend to occur at its boundaries or the extremes. Now you can consider the different set of examples that are presented here. You can pause the video for a minute and then analyze your boundary cases and write down them, and you can verify them with the next slides. These are the different set of boundary cases for the first example, and these are the different set of boundary cases for the next example. You can go for better understanding, you can go through with this given example and write down the boundary cases. And here is one assignment that a viewer can consider for how much he has understood by viewing this video. Thank you. Hope you have enjoyed the video.